Hello guys, welcome to my channel. Today we will be discussing about quadrilaterals, rigorous discussion on quadrilaterals. We will be discussing all about the properties of quadrilateral. So without wasting a time, let's start the class. Quadrilateral means four-sided polygon. So you see there are several shapes here. This is what? A triangle. This is quadrilateral. You can say pentagon. This is a circle. This is not a quadrilateral. Why? Because they don't have straight sides. They don't have straight lines. It's a curve. It doesn't have a straight line. So not a quadrilateral. Pentagon. It has 5 sides. So not a quadrilateral. Triangle. 3 sides. Not a quadrilateral. So when we say quadrilateral, that shape on a plane should be a closed shape with 4 sides. Any shape. This is a quadrilateral. It has 4 sides, A, B, C, and D. This is a quadrilateral. 4 sides, A, B, C, D. This is a quadrilateral. A, B, C, D. All the quadrilaterals, this will tick mark the quadrilaterals. These are quadrilaterals. These are quadrilaterals. Quadrilateral. No, no, no. All these quadrilaterals, they have 4 sides. They have 4 angles. They have 4 vertices, corners, 4 sides. Let's take this example. AB, BC, CD, and D. 4 sides. 4 angles. Angle A, angle B, angle C, angle D. 4 vertices. A, B, C, D. Any quadrilateral will have that. When you connect with a line, the opposite vertices, it will give you 2 triangles. You take this and touch this, connect this, 2 triangles. Connect this, 2 triangles. Connect this, 2 triangles. This is required to prove that the angles inside a quadrilateral is 360 degrees. Side AB and AD, adjacent sides. AB and AD, this and this are adjacent sides. BC and CB are adjacent sides. CB and BA are adjacent sides. AD and BC are opposite sides. AB and DC are opposite sides. We are talking about these two, or these two, or these two, or these two. This and this are adjacent angles. This and this are adjacent angles. This and this are adjacent angles. And this one means angle A and angle B are adjacent. Angle B and angle C, they are also adjacent. Angle C and angle D, they are also adjacent. And angle A and angle D, they are also adjacent. There are 2 things, sides and angles. This and this are adjacent sides. This and this are adjacent angles. My purpose here to explain adjacent sides and adjacent angles, opposite sides, opposite angle. The purpose is you have to understand. You need to have the clear understanding what is opposite side, what is opposite angles, which are the opposite angles. So when we talk about opposite angles, we can say this angle. We'll not name it, but just we'll show pictorially. And these angles, these 2 angles, means angle A, angle C, or you can say angle BAD or BCD. They are opposite. Similarly, this is opposite. These 2 are adjacent angles. These 2 are adjacent angles. This side is opposite of this side, and this side is opposite of this side, and this side is adjacent to this side, or you can say this side is adjacent to this side. Both are same. So every side has two adjacent sides, and every angle also have two adjacent angles. For this is also adjacent angle. But for every angle, there is only one opposite angle. For this, only this one is opposite. But for this is adjacent and this is also adjacent. Let's draw some random quadrilaterals. All are closed shapes, and they look different, but they are quadrilaterals. Let's start with rectangles. The properties of a rectangle. Rectangle is a quadrilateral, opposite sides equal. So this is equal to this and this is equal to this. All angles are 90 degrees. Opposite sides are parallel. So this is parallel to this and this is parallel to this. If you join AC, this is what? This is a diagonal. Join the opposite vertices of the rectangle. So AC is a diagonal. You can join the opposite vertices here also. And you can say BD and AC, they are the diagonals of. Diagonals are of equal size. In rectangle, the diagonals are always equal. Diagonals bisect each other. When you join the diagonals and you measure AC and you measure BD in any rectangle, you will find it is same. And when you measure, let's say they meet at point O. These diagonals, they meet at point O, and if you measure AO and OC, they are equal. And if you measure DO and BO, they are also equal. So they are bisecting also. So this part is equal to this and this is equal to this. Or you can say AO is equal to BO, BO is equal to CO, CO is equal to DO. Because diagonals are already equal. They are equal and half also. They are equal, both are equal, and this is the midpoint of the diagonal. So you can say this is equal to this and this is equal to this, but both are equal. So AO, BO, CO, DO are always equal. So let us say this angle is 30 degrees. Let's see what are the other angles. And this is a rectangle. Same diagram. Rectangle. So we have to find all the angles. We have to find 1, we have to find 2, we have to find 3, we have to find 4, 5, 6, 7, 8, 9, 10, 11. Angle ADC is 90 degrees. We'll start from here. It is already 90, all angles 90. So angle ADC is 90 and angle ODC is given. So angle 7 is equal to ADC, angle ADC minus angle ODC. Total is 90. If you minus 30, you get 7. So it will be, let's say 60 degrees. If this is 60 degrees, this is also 60 degrees because angle 1 is equal to angle 7. Because in triangle AOD, AO is equal to DO. Isosceles triangle. Similarly, 2. Total is 90. This, you know, angle 1 you know 60. So angle 2 will be 90 minus 60. Correct. Similarly, this is 30, then this is also 30. If this is 30, then this is also 30. If this is 30, 90 minus 30 by calculation, and by writing C minus angle ABD, you get angle DBC, 60. If this is 60, this is also 60. 60, 30, 30, 60, 60, 30, 30, 60. This is 60, this is 60 in a triangle 180 degrees. So this is vertically opposite angles. Linear pairs. Linear pairs. Linear pairs means on a line, the total sum of the angles is 180 degrees. It's a supplementary linear pairs. So 180 minus 60. So this is how we calculate all the angles in a rectangle. If one is given, then you have to use the standard properties of a rectangle to find out the angles. One of the quadrilateral is called rectangle. Let's say this is a square. In a square, let the vertices be A, B, C, D. In this, all the sides are equal. This equal to this equal to this. AB equal to BC, opposite sides are parallel. So, AB parallel to DC and BC parallel to AD. All angles are 90 degrees. BAD, ADC, DCB, all are 90 degrees. Diagonals are equal. AC is equal to BD. Diagonals bisect each other. Diagonals are equal means AC is equal to BD. And that when you join the vertices, the two diagonals, they bisect each other. That means AO is equal to CO and DO is equal to BO. But diagonals are equal. So DO is equal to CO, BO is equal to AO. AO equal to DO, DO equal to CO, CO equal to BO. All are equal. This is equal to this. All are equal. And one very interesting thing. The diagonals bisect the angles. When you join these two diagonals, make these two diagonals by joining these two vertices, this is equal to this. Square can be, this is a square, it can be a, this is a square or this is a square. But these are same for all the squares. Same for this, and same for this. When we say square, these are the characteristics. All sides are equal. AB is equal to BC, BC. Opposite sides are parallel. This is parallel to this, and I'll put a double line here because they are different parallel lines, opposite parallels. All angles are 90 degrees. Diagonals are of equal size. AC is equal to BD. Diagonals bisect each other. This is equal to this. We'll prove this. Let's find all the angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's find all the angles. If this is 45, this is 45. If this is 45, 90 minus 45, 45, 90 minus 45, 45, 90 minus 45. If this is 45 angle, this is 45 degrees, 90. So what is left? 90. 90 in a triangle, total 90, 180 degrees, minus 90 is 90. So this is 90 degrees. This is 90 degrees. This is 90 degrees. This is 90 degrees. One more. The diagonals are perpendicular to each other. This is line AB. This is line CD. CD, I am saying perpendicular. CD is perpendicular to AB. That means CDB is 90 degrees or CDA 90 degrees. So when this is 90 and this is 90, this is called perpendicular. So CD is perpendicular to AB. This is very important because in many quadrilaterals, you will find some have this properties, some don't have. This is a parallel. This is parallel to this. So this is a transversal. So this angle and this angle, these two angles are interior opposite angles. They are equal. So you take any parallel line, make a transversal. This angle is A, this angle is A, this angle is A, this angle is A. So this and this, they are interior opposite angles. These two are vertically opposite angles. Then you can say this is so this, if this is B, so B is what? B is linear pair of A. A plus B is 180 degrees. Vertically opposite, this is B. This is also equal to this. You can take this also transversal, you can take this also transversal, whichever you want, you can take. Parallelogram. It's a quadrilateral. In this quadrilateral, which is called parallelogram, the opposite sides are parallel. Opposite sides are equal. You take any two line, draw a line, parallel line, and you draw any parallel line like this. So this is parallel to this, and this is parallel to this. This is a parallelogram. Opposite sides are equal. So AD is equal to BC and AB is equal to DC. Opposite angles are equal. Adjacent angles add to 180 degrees. If this is X, this will be always 180 minus X. Opposite angles are equal. This is always equal. So this is also equal. When you add, it is 360. You add this adjacent 180. You add this adjacent 180 degree. 180, 180. Any two angles you take, add 180. In opposite, always equal. Diagonals cannot be equal. Let's say we can say rectangle is a special parallelogram. Square is a special parallelogram. They have diagonals equal. But in all the parallelograms, diagonals are not equal. You can make a, see, like this, a parallelogram. You can make like this. You join this. They are not equal. So diagonals are not. Diagonals bisect each other. Any quadrilateral, if they have opposite sides parallel, definitely they are called parallelogram. If opposite sides are parallel, this will happen automatically. So if this is satisfied, then it is a parallelogram. Opposite sides are parallel, it is a parallelogram. In square, opposite sides are parallel, it's a parallelogram. In rectangle, opposite sides are parallel, parallelogram. Rhombus. We discussed some properties of rectangle, properties of some squares, parallelogram. In a rhombus, it's a quadrilateral with all sides equal. All the sides of a rhombus are equal. Opposite sides are parallel. Diagonals bisect each other. Rhombus. You join these two. All the sides are equal. Diagonals are of not equal size, like in parallelogram. The diagonals are not equal size. But these two diagonals, they bisect each other. So this equal to this and this equal to this. Or diagonals are perpendicular to each other, like in square. If you join the diagonals, all this angle 90, 90, 90, 90. Diagonals bisect the angles. This equal to this equal to this equal to this equal to this. So all the sides are equal, opposite sides are parallel, diagonals are perpendicular to each other, and diagonals bisect this angle DCB, angle CBA, angle BAD, angle ADC. So BD bisects the angle ADC. Let's say if it is 60 degrees, if you join the diagonal, if you measure, this will be 30, this will be 30 in rhombus. Let's draw a hierarchy. So they are classified as per their properties. All the quadrilaterals which we are learning now, they have different properties and they can be grouped. All the squares are rhombus. Rhombus is not a square. So arrow is going inside it. All those squares are rectangles. The definition in rectangle is the opposite sides are equal. I'm not saying all sides equal. In square, opposite sides are equal. All the sides equal means opposite sides equal. But here opposite sides equal only. So here also opposite sides equal. So whatever property is here, it has all those properties. Whatever properties rhombus has, this has all the properties. So square is a, you can say, special rectangle. Square is a special rhombus. All the rhombus are parallelograms. This is a rhombus and this is a parallelogram. In parallelogram, opposite sides are parallel. Here also opposite sides are parallel. In rhombus, opposite sides are parallel. The moment the opposites are parallel, it is a parallelogram. Square is also a parallelogram, but square doesn't come inside it directly. A square is a rectangle. Rectangle is also but we can, if somebody asks you, square is a parallelogram, answer is yes. Square is a quadrilateral, yes. Square is a trapezium. Let's take a rectangle. See, rectangle is a parallelogram, yes. Rectangle is a trapezium, yes. Rectangle is a quadrilateral. Rectangle is a square. No. Square is a rhombus, yes. Isliye arrow is very important. Yes, 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 yes. Rhombus is a parallelogram. Kite is a quadrilateral in which the adjacent non-overlapping sides are equal. Adjacent sides in this quadrilateral are which ones? AD. So this is adjacent to this also, and this is adjacent to this also. So in a kite, the adjacent sides are equal, but we use a word there, non-overlapping. That means if we take these two sides equal, we are not considering these two sides next time. We are considering this and this separately. Non-overlapping. Once we have taken these two sides, then other two sides are equal. Non-overlapping. This is already taken. No other two sides. This is already taken, these two sides. So adjacent sides are equal, non-overlapping sides. Adjacent, non-overlapping. Take any kite, any quadrilateral, and you say this is equal to this, and this is equal to this. A, B, C, D. This is a kite. Rhombus is a kite. Why? In a rhombus, all sides are equal. This is a this is what? This is a kite. I take a rhombus like this. This equal to this. and this equal to this, all sides are equal. So here, these sides are equal and these sides are equal. So it is a kite. In kite, what is the definition? Adjacent sides equal, adjacent equal, non-overlapping, separate two sides, separate two sides. Take a rhombus. Rhombus with all sides equal. Forget about equal sides. Forget it. Adjacent sides equal. Non-overlapping also equal. Forget about all sides equal. Forget it. Just see the definition and repeat the definition. In a rhombus, all are equal. 4 centimeter, 4 centimeter, 4 centimeter. Forget it. So rhombus, adjacent sides equal, and the non-overlapping sides are also equal. So rhombus is a special kite. Arrow. Kite is not a rhombus. Rhombus is a kite. Square is a rhombus. Square is a kite also. When you take a square like this, this side equal to this side, and the other two sides also equal, non-overlapping. So square is a rhombus. Rhombus is a kite. Kite is a quadrilateral. Square is a rhombus. Rhombus is a parallelogram. We'll come to this. Square is a rectangle, and rectangle is a parallelogram, and parallelogram is this. Let's see what is a trapezium. Again, one line definition. Any quadrilateral, one pair of opposite sides are parallel. Thank you for watching the video. If you like the video, please like and subscribe. See you in the next class. Bye-bye.